Hello there. In today's video, we're going to talk about solving systems of equations with three variables. This is a system of equation. That just means a group of equations. In this case, we have three variables, x, y, and z, and we're looking to solve for all three of those. So we're going to use a process called elimination method to solve this. So I'm going to label these A, B, and C. The first thing we're going to do is we're going to, instead of having three equations with three variables, we're going to see if we can make this be two equations with two variables. So over here, I'm going to write AB. Your first step is declare which variable you want to eliminate first. And it doesn't matter which one you pick. I'm just going to declare arbitrarily Z. I want to get rid of all the Z's in the problem. And I'm going to use equations A and B to do that. So equation A is 3x plus 4y minus z equals 2. Equation B is 9x plus 8y minus 6z equals 4. To use the elimination method, we need the variable I just declared to be the opposite of the other variable I just declared. So we need both of these to be opposites. I declared I want to get rid of the z's. So I need one of them to be positive 6z, and I need one of them to be negative 6z. I just need them to be opposites. I don't care what the numbers even are. So let's make this one be opposite by multiplying everything by negative 6. And that'll give us negative 18x minus 24y plus 6z equals negative 12. And I'm not changing the bottom equation. So to use the elimination method, we declare a variable that we're trying to eliminate, and we make them opposites of each other using multiplying. So now that we have opposites, I can add. Opposites go away when you add. So let's add these two. Negative 18x plus 9x is negative 9x. Negative 24y minus or plus ay is negative 16y. 6z plus negative 6z eliminates the z's. And negative 12 plus 4 is negative 8. All right, we're going to put a pin in that equation. We're going to come back to it. Now we need to pick a different pair of equations and do the same process. So I just used A and B. Let's use B and C. So equation B and C is 9x plus 8y minus 6z equals 4. 5x plus 6y minus 3z equals negative 2. Same thing, I'm still trying to eliminate the z's. Same thing, I still need them to be opposites. Those are not opposites. So if I multiply the bottom equation by negative 2, then they will be opposites. So now we have 9x plus 8y minus 6z equals 4. And negative 10x minus 12y plus 6z equals 4. Hey, look, the z's are opposites, so I can add. Adding makes opposites go away. Negative 9 plus negative 10 is negative 1x. 8 plus negative 12 is negative 4y. Opposites cancel when I add, and 4 plus 4 is 8. So now I have my wish. Instead of three variables with three equations, now I have two variables with two equations. So let's write them above and below each other. And we'll do the same thing we just did. We declare a variable and then try to get rid of it. So out of these two equations, I'm going to declare I want to get rid of the y. To do that, I need them to be opposites. So I'm going to multiply this bottom equation by negative 4. So that'll be negative 9x minus 16y equals negative 8. And then the bottom one will be 4x plus 16y equals negative 32. These are opposites, so let's add. Adding makes opposites go away. Let's add those to get negative 5x and negative 40. And now I just have one variable to one equation. I can divide by 5, negative 5. And we get x equals 8. So all of that work was to get x equals 8. Now we need to go back to the other equations to get y and z. So let's go back to one of these equations to get y. Because now that I know x is 8, I'm going to change. I'm going to change x to be 8 in this problem. So negative 1 times 8 is negative 8 minus 4y equals 8. And that to this side, you get 16, and y is negative 4. Almost done. Once you have one variable, you go back to these two and plug it in to find the second variable. And once you have both x and y, go back to one of the original equations to find the third one. So let's go back. Let's plug it into the first equation. X we just found out is 8. Y we just found out is negative 4. I still don't know z, so let's find it. 8 times 3 is 24. 4 times 4 is negative 16. 24 minus 16, 8. 8 minus z equals 2. This is going to be negative z is negative 6, or z equals 6. So there we go. It took all that work, but we found all three variables. These are the only three variables that will work in all three of these equations. And that's solving a system of equations with three variables. Thanks for watching.